In the vast and silent expanse of our galaxy, one filled with frozen gas giants, lifeless rocky planets, and the endless quiet of space, there lies one world that refuses to follow the expected rules of planetary behavior. That world is K2-18B, orbiting a cold red dwarf star over 110 light-years away in the constellation Leo. K2-18B has emerged as one of the most promising candidates for life beyond Earth. 4 years, astronomers observed anomalies that hinted at something extraordinary. First, they detected signs of water vapor. Then came the discovery of carbon-based molecules. But now, thanks to the unparalleled capabilities of the James Webb Space Telescope, we are seeing atmospheric details that challenge pure chemical explanations. What Webb has uncovered has sent shockwaves through the scientific world. Clear biosignatures, the strongest ever observed on an exoplanet. These are gases that, on Earth, can only be produced by life. This is no longer speculation. This is hard data. And with it, we may be standing on the threshold of admitting that we were never truly alone. K2-18B's classify it as a Hycean world, a term used to describe a hybrid planet featuring vast oceans beneath a hydrogen-rich atmosphere. It is significantly larger than Earth, about 2.6 times the radius and approximately 8.6 times the mass. Yet, what truly sets it apart is its location. It orbits within the habitable zone of its star, the narrow region where temperatures are just right for liquid water to potentially exist. Unlike Mars, with its dry, barren surface, or Jupiter, a swirling ball of gas, K2-18B may be an ocean-covered planet cloaked in a thick atmosphere that not only regulates temperature, but also shields the surface from harmful radiation. Webb's analysis has revealed the presence of water vapor, carbon dioxide, and methane, all critical ingredients for organic chemistry and potential biological activity. In a hydrogen-rich world, the presence of these gases together paints a compelling picture, one in which biological processes may be shaping the planet from beneath its watery surface. The biggest revelation came in 2025. New data from the James Webb Space Telescope's mid-infrared instrument MIRI detected something far rarer: dimethyl sulfide DMS. On Earth, DMS is almost exclusively produced by living organisms, particularly marine phytoplankton. Finding this molecule in an alien atmosphere is comparable to discovering oxygen on Mars. It's not just chemistry anymore. It's a signpost for biology. And this wasn't the only discovery. Alongside DMS, researchers found dimethyl disulfide, DMDS, another complex organic compound tied to microbial activity in Earth's oceans. The simultaneous presence of these two molecules in an environment rich in water vapor and carbon-based gases has led scientists such as Cambridge astrophysicist Dr. Niku Madhusudan to propose that K2-18B may be teeming with microscopic alien life. These are not exaggerated headlines. These are statistically significant, reproducible molecular signatures that have pushed the scientific community to seriously consider the idea of a living alien world. So what kind of life could exist on K2-18B? If the detected DMS truly originates from biological sources, the most likely explanation is that its oceans harbor life similar to Earth's phytoplankton, tiny, floating microorganisms that could use the faint red light of their cool sun to perform photosynthesis. Some scientists speculate even further, imagining more complex ecosystems. There could be filter-feeding organisms resembling Earth's earliest multicellular life, drifting through the nutrient-rich waters and leaving behind chemical footprints. Others hypothesize the existence of unique alien life forms, adapted to low gravity and high-pressure environments, perhaps even creatures capable of limited movement through the atmosphere. Like distant analogues to flying fish, in essence, K2-18B might not mirror modern Earth, but could resemble our planet 3 to 4 billion years ago, when life was just beginning to bloom. And just as Earth's early biosphere gradually altered its atmosphere, the same transformation might be unfolding there, and we may be witnessing it in real time. As evidence mounts, an urgent debate has begun. If K2-18B harbors life, should humanity try to communicate? Some experts warn against it. Physicist Mark Buchanan cautions that initiating contact could expose Earth to unknown risks, including interactions with a civilization we are unprepared to face or potentially damaging a fragile alien biosphere. Ethical philosopher Dr. Anthony Milligan argues that we have a moral responsibility to act cautiously, not just for our safety, but to protect whatever might exist there. Meanwhile, astrophysicist Avi Loeb offers a different view. If any intelligent beings reside on K2-18B and are advanced enough to detect our signals, they likely already know about us and may not consider us worth engaging. Regardless of one's stance, one fact remains: any signal sent from Earth would take 120 years to reach K2-18B and another 120 to receive a reply. For now, we wait, but the data continues to pour in. The molecules are present, the ocean is likely, real, and the long-held belief that we are alone is becoming increasingly untenable. With K2-18B now commanding the attention of the scientific world, both public and private space agencies are rethinking their priorities. Although no current propulsion system can reach this ocean world in under several centuries, plans are taking shape to enhance our observational capabilities. NASA is accelerating the development of its Lovelock and Habakk's observatories' next generation space telescopes designed specifically to identify life-bearing exoplanets by studying atmospheric chemistry. The European Space Agency and China's CNSA are also preparing their own advanced exoplanet monitoring missions. But interest doesn't stop at observation. The concept of launching an interstellar probe to K2-18B, possibly propelled by lasers and solar sails, is gaining momentum. The Breakthrough Starshot initiative, supported by billionaires and leading scientists, envisions sending tiny probes at 20% the speed of light. If realized, such a mission could reach K2-18B in roughly 500 years, a long wait for humanity, but a mere blink on the cosmic timeline. Even if we never set foot on its shores, we may one day receive a reply to a message sent across the stars. While the scientific implications of K2-18B's possible biosignatures are immense, the cultural impact may be even greater. Across the globe, religious leaders, philosophers, and spiritual thinkers are grappling with the meaning of this discovery. Some see it as evidence that life is not unique to Earth, but part of a grand, interconnected cosmic design, a universe engineered for consciousness. Others respond with fear or denial, warning that humanity may not be psychologically prepared to face such a reality. Social media is alight with hashtags like #K2Alive and #OceanWorld, while documentaries and fictional stories inspired by K2-18B already in production. Government officials remain cautious in their public remarks, balancing enthusiasm with scientific discipline. But beneath the surface, a quiet but profound shift is taking place, a global realization that we are no longer just explorers of the cosmos, we are possibly being observed in return. And in that recognition, a rare moment of global unity is emerging, not driven by fear, but by wonder. As interest in K2-18B grows, so does the call for ethical planetary protection, not for Earth, but for the alien biosphere we may have discovered. International bodies are now convening to draft proposals for a new category of protected planets, exobiological sanctuaries. These would be exoplanets where signs of life have been detected and which must only be studied from afar to prevent contamination. Astrobiologist Dr. Monica Vidari insists that if K2-18B does host life, it has evolved in isolation for billions of years. Humanity, she argues, has no moral right to interfere. Some proposals even advocate for a kind of interstellar no-fly zone, restricting probe paths and emissions to avoid disturbing delicate alien ecosystems. These discussions reflect a maturing perspective. Just because we can reach or observe a place doesn't mean we should intrude. Even if the oceans of K2-18B are quiet now, even if the life is microscopic, it is still the first confirmed example of our cosmic kin, and if we are wise, we will learn to listen before we act. Ultimately, the most profound revelation of K2-18B may not be what it tells us about aliens, but what it reveals about ourselves. Here is a planet that may host oceans, clouds, and the precursors or perhaps even the presence of life, just as Earth once did in its earliest days. Observing K2-18B is like peering into a mirror from the past, offering a glimpse of how life may have started on our own planet. It reminds us how fragile life is, how rare the right conditions can be, and how valuable our own world truly is. Some scientists believe K2-18B could help unlock secrets about the origin, adaptation, and evolution of life knowledge that could help us preserve our own biosphere. Others see this as a turning point, a moment when science, philosophy, and wonder converge on a single, powerful truth. Life is not the exception in the universe, it may be the rule. In the cold silence of space, we may have found not a stranger, but a reflection of our own beginnings, and a hint of what we might still become. K2-18B is no longer just a distant blip on a star chart or a forgotten data point in a telescope's archive. It is now a beacon of possibility, a place that, against all odds, whispers the same chemical secrets as our own living planet. And in that whisper, something fundamental has shifted. For decades, we asked the same question: are we alone?